Very good evening everyone and welcome to the session. Yes, chalo. So let's get started. This is the particular session on the properties of Laplace transform. Because in the last two sessions we have been seeing the basic, firstly I started with the basic concept of Laplace transform and ROC, what Laplace transform is, what ROC is, right, where all they can be used, and what is the Laplace transform of some basic signals, the calculation part. Okay, why ROC comes up. Then next class we took up completely on properties of ROC because that is a very important and conceptual part. So what are the different properties and rules followed by the ROC? That was discussed, and in this particular class I'm going to talk about the properties of Laplace transforms. Okay, and then eventually moving forward our next class would be, just a second, so eventually moving forward the next class, that is going to be the question practice on the Laplace transform. Okay, so let's get moving ahead, let's get started here. Okay, this is the introduction part, you all know. And yes guys, a very important update that this Sunday 21st of May straight at 12:30 p.m. live from the studio, all your favorite, the dashing Joshit Singh sir, MTech IIT Roorkee, and having more than 5 years of experience, is going to take up a free GATE workshop. Yes, this GATE workshop is on the BYJU'S exam prep app, not on the YouTube. It's on the application, BYJU'S exam prep application, and in this you are going to learn about the detailed strategy to secure a rank under 100. Yes, the detailed strategy to secure rank under 100 in GATE 2024. Right guys? Okay, right, so let's get moving ahead then. Okay, the properties of Laplace transform. Okay, number one is the linearity, which is there for most of the transforms, is that when two signals are added, the Laplace transforms are also added. If x1t has the Laplace transform x1s, x2t has the Laplace transform x2s. Now every Laplace transform we know will have some ROC. Okay, so suppose the first signal has some ROC R1, second one has some ROC R2. Now what about the Laplace transform of a1 x1t plus a2 x2t? Yeah, it could be minus as well. Okay, any linear combination. The Laplace transform is given as per the linearity property a1 x1s plus a2 x2s. What about the ROCs now? For ROC I've already conducted the last class, which is the property of ROC, and there we have learned all concepts regarding to ROC. Here I will mention some basic points about ROC, but we will be more logical in ROC approach rather than this point. ROC is such that, because two signals are coming, both have their own ROC R1 and R2. So ROC should be such that at least both of them are satisfied. Okay, and both of them can be represented, both of them means common, and that common can be represented by intersection. So ROC must be containing R1 intersection R2. Now let's understand. Okay, here simply let's take an example to understand this point. Okay, so suppose you have e power minus 2t ut plus e power minus 3t ut. These are the two signals given to you. What is the Laplace transform and ROC? Both we need to figure out. What is the Laplace transform and what is the ROC? Both we need to figure out here. Okay, so let's start working on both. Okay, so what is going to be the Laplace transform? So I hope you remember the basic Laplace transform here. Okay, let us have a quick revision before starting this particular problem. Just a moment. Yeah. Right. So we all should now recall that for e power minus at ut, the Laplace transform is 1 upon s plus a. For the ROC, sigma greater than minus a. Right. And similarly for e power minus at u of minus t, the left-sided signal, this has the Laplace transform minus 1 upon s plus a, but with the left-sided ROC, sigma less than minus a. Correct. So for e power minus 2t ut plus e power minus 3t ut, what should be the Laplace transform xs, the complete Laplace transform xs for e power minus 2t ut, 1 upon s plus 2. For e power minus 3t ut, 1 upon s plus a, again that is 1 upon s plus 3. But okay, now let me write down both of the ROCs. For this, ROC is sigma greater than minus a, that is sigma greater than minus 2. For the second one, it is sigma greater than minus 3. Now, what is the final ROC? As I told you, final ROC should be satisfying both. So I should be taking next I should be taking next the intersection. Sigma greater than -2 intersection with the sigma greater than -3. Sigma greater than -2 intersection with the sigma greater than -3. That is what is the ROC. Now, what is the intersection of that? Sigma should be greater than -2 as well as greater than -3. Okay, we look into this picture. Sigma should be greater than -2. Let me highlight the poles little bit more clearly. These are the two poles, -2 and -3. Okay, sigma should be greater than -2 as well as greater than -3. So of course it has to be greater than -2, because if it is greater than -2, automatically it is greater than -3 as well. Na? It has to be greater than the greatest number. Okay, so the combined ROC that can be mentioned here is sigma greater than the larger number, and larger of these two is -2. Sigma greater than -2 is the final ROC. Okay, and then this result can be simplified. That is okay. S plus 2 plus S plus 3 will become 2S plus 5 divided by S square. S plus 2 S plus 3 will become S square plus 5S plus 6. 2S plus 5 upon S square plus 5S plus 6. Correct hai ji? That is what it is. Okay, that is what it is. Okay, done. Right, okay, cool. Chalo. So sigma greater than -2 is the final ROC, and that is sketched in front of you. One more thing, if you recall, I told you in the last class only ki whenever it is a right-sided signal, so UT and UT, both the signals are containing UT, matlab it is ultimately right-sided signal. And whenever you have a right-sided signal, ROC is also right-sided, lying to the right of the rightmost pole. So there are two poles. Automatically it has come up. There are two poles, -3 and -2. Which is the rightmost pole? Which is the largest pole? -2. ROC is to the right of the rightmost pole. Okay, actually ROC is right of all the poles, because ROC cannot contain any poles. That is also one more property about ROC, na? So let's move ahead to next case here. Okay, we are taking some fundamental questions on linearity, and then we will move to other properties. Next is e power -3 ut with plus e power 2t u minus t. One right-sided, one left-sided. Okay, one right-sided, one left-sided. Okay, so if let me highlight, the previous one was completely right-sided. Now this question that I am giving is ut and u minus t. That means it is a two-sided signal. This particular signal that I have been giving you is a two-sided signal, isn't it? It's a two-sided signal. Now we know that what could be the ROC of two-sided signal. There can be some expectation in the mind already, isn't it? There can be some expectation in the mind already. Okay, so let me start solving it. We will have x of s equal to e power -at ut 1 upon s plus a. ROC sigma greater than -a plus e power 2t u minus t. Okay, so e power -at u minus t has -1 upon s plus a. So this is -1 upon s plus a, but a here will be -2, so -1 upon s minus 2. ROC sigma less than a, sigma less than -a, which will be equal to 2 here. Okay, which will be 2 here. Okay. Right. So now what is the final ROC, dear? What is the final ROC? It is such that it satisfies both. Okay, the sigma should be greater than 3, but sigma should be less than 2. Sigma should be greater than -3, I'm sorry, but sigma should be less than 2. So what is the common ROC that you can expect here? Greater than -3, but less than 2. Matlab between -3 up to 2. Greater than the -3, less than the 2. This is the ROC. And what about the final expression? Let me solve that to s -2 minus s -3. S and s will get cancelled. -2 minus 3. This will be -5, and denominator will be s plus 3 s minus 2. The s square, then plus of s, and 3 minus 2 minus 6. So -5, the final answer is, if they ask Laplace transform, it is -5 upon s square plus s minus 6. And if they ask ROC, it is -3 less than sigma less than 2. They can ask both also. But commonly for this, two different signals given in the form of addition, the common questions are mostly about ROC. Okay, so ROC is common to both. Intersection you have to consider. Okay. Two-sided signal. Now again important point, what we have seen in the last class only, for a two-sided signal, ROC contains of a finite strip in the S-plane between -3 se 2. Have a look into the picture. Between the -3 se 2, let me highlight the poles once again. Between the -3 up to the +2. ROC is what? It is just a finite strip. Okay, a finite strip between the two poles. Clear? Between the two poles. That is what it is. Moving ahead to the next one. E power 2t ut plus e power minus 3t u minus t. E power 2t ut plus e power minus 3t u minus t. Just a second. Yeah. Come on. E power 2t ut plus e power minus 3t u minus t. Tell me this one. Again, what type of signal it is? ut, u minus t. Okay, both the parts are coming. Matlab it is again two-sided. It is again two-sided. Now let us see what are the results for this. Okay, so first let me calculate the basic Laplace transform. The Laplace transform is e power 2t ut plus e power minus 3t u minus t, e power 2t ut. Okay, 1 upon s minus 2. So a is minus 2. But this is right-sided, to sigma greater than minus a, that will be sigma greater than 2. That is the ROC. Plus e power minus 80 u minus t. So minus 1 upon s plus a. Minus 1 upon s plus 3. ROC left-sided. Sigma less than minus a. Sigma less than minus 3. Okay. Now, what is the final ROC? It should be such that it is containing both of them. Okay, it is the intersection of both. Sigma greater than 2 and sigma less than minus 3. Now decide and tell what can be the ROC. Bhai sahab, sigma should be greater than 2. At the same time, it should be less than minus 3. Is it possible? If a number is less than minus 3, it is already less than 2. It cannot be greater than 2. Or vice versa, if the number is greater than 2, it is automatically much greater than minus 3. Right? So that means, what does it mean? That there is no common ROC. There is no common ROC. That means there is no ROC for this signal. Now please don't start calculating this. You may start calculating s plus 3 minus s minus 2. That will become 5. 3 minus 1 is to correct upon s square plus s minus 6. Okay. You may start calculating this, but this is wrong. Okay. There is no ROC. So I can say that Laplace transform for this signal does not exist. Because what ROC is? Region of convergence. The region in the S-plane for which Laplace transform would be defined. But there isn't any region in the S-plane here. Because there is no ROC, there isn't any region in the S-plane for which Laplace transform is defined. And hence there is no Laplace transform. So by chance don't write down this answer particularly. It's going to be wrong. Let's move ahead to the next case. Now the time shifting case. Okay, that was linearity. And again, I'm telling you the important cases with linearity are mostly about ROC. Selecting the correct ROC, and that is obtained by intersection. Okay. If xt has the Laplace transform xs with the ROC being equal to r, x of t minus t naught, like all other transforms as well. Okay, the time shift will produce the exponential term xs e power minus st naught. The Laplace transform will be xs e power minus st naught without any change in ROC. Without any change in ROC. Now, why there is no change in ROC? Acha, when I am talking about properties of Laplace transform, only remember the property of Laplace transform. Not necessary to remember the ROC property. Because if you have followed the previous class of ROC, or if you have not followed, you can watch it again. The previous class of ROC, if you understand the logic of ROC, it cannot contain any poles, right? Okay, for right-sided, it is right-sided. For left-sided signal, it is left-sided, etc. There are some fundamentals I talked in the last class. If you mix with, you don't have to remember this. Okay, so ROC is decided by poles and the nature of the signal. Okay, now have a look into this. What is the Laplace transform for ut minus 3? For ut minus 3. Now, we have seen that in the last classes only, that what is the Laplace transform for the unit step signal? For the unit step signal ut, the Laplace transform is given by 1 by s. It is given by 1 by s. For ut, it is given by 1 by s, correct? So what should be the Laplace transform for ut minus 3? Acha, 1 upon s, and what is the ROC? Remember, the ROC is sigma greater than 0 for unit step. Even if you don't remember, no problem. Still there isn't any problem. Because, dekhiye na, what is the pole of this? Pole is s equal to 0. Right? Okay. So s means s equal to 0. The sigma is also 0 because s is sigma plus j omega. S is 0 means sigma and omega both 0. Okay. Now I know the pole. ROC is confined by poles only. Now the nature of the signal, right-sided. So ROC should also be right sided, greater than 0. That's it. So even if you don't remember ROC, not a big deal, but remember the important properties of ROC of the last class. Done hai ji? Okay, ठीक है. So anyways, if you remember or if you do it by logic, the ROC is sigma greater than 0. Now here we are interested for u of t minus 3. For u of t minus 3. So as per this time shift property, whenever there is time shift, there is going to be an exponential term. So 1 upon s e raised to the power 3s. 1 upon s e raised to the power minus 3s. I'm sorry, I missed the minus. 1 upon s e power minus s t naught, and t naught value is 3. So e power minus 3s. And I told you in the property no change of ROC. But don't remember that point. Na? Only remember the Laplace property. ROC you decide on your own. What is still the pole? What is still the pole? The still pole is s equal to 0. S equal to 0. Right? Still the pole is at origin only, s equal to 0. What is the nature of the signal? ut minus 3. Ultimately ut minus 3 is right shifted, but it is right sided only. Na? What happens to ut minus 3? It starts with t equal to 3. But eventually where it is going? It is going towards right. It is a right sided signal. Whenever it is u plus t, shifting kuch bhi kar do. Whenever it is u plus t, it is right sided. When u minus t comes, that is mirror image, that is left sided. Okay. So signal is what? Signal is right sided nature. Okay, so looking into these two conditions, I can decide the ROC. Na? I can decide the ROC. What is the ROC? Right sided signal, ROC is also towards right. So sigma greater than something, greater than what? It has to be greater than pole because it cannot contain the pole. So is there any change in the ROC? No change. Okay, but you just do it by logic. Do it by the ROC logic. Okay, done hai. This is what is the answer. Okay. Next case. Okay, summation delta t minus kt. Find the Laplace transform for, okay, summation delta. Okay, let me expand this word. What does it mean? Summation k equal to 0 to infinity delta t minus kt. So if I start with k equal to 0, the first term is delta t. Then the next term is delta t minus t, k equal to 1. Next is delta t minus 2t. Next is delta t minus 3t, etc, 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 up to infinity. Up to the infinity. Correct. So what is going to be the Laplace transform then? The Laplace transform will be delta t, Laplace transform 1. Delta t minus t, Laplace transform e power minus st, 1 into e power minus st, because it is the time shift application. Na? Because it is a time shift application. Next, what you are going to get is 1 into e power minus st, e power minus 2st, because time shifting here is by 2t. Next is 1 into e power minus 3st until infinity. This is the Laplace transform which we will further simplify. Okay. Now, what is the ROC first of all before I simplify? What is the ROC for 1? 1 is constant. There is no pole. E power minus st also, there is no denominator term, there is no pole. None of the terms has any pole, and because there is no pole, ROC can be, ekdam khulli chhoot mil gayi na. There is no poles, ROC can be everywhere, entire S-plane. Entire S-plane. ROC here is entire S-plane. Because there is no pole, so ROC is entire S-plane. Okay. There is no pole seen in the function. ROC is entire S-plane. Now final answer for XS. Okay. Now we can apply the geometric formula, the geometric progression GP formula. It is just following a GP. Every time e power minus st, e power minus st is getting multiplied. This is e power minus st. This is e power minus st square. This is e power minus st cube, and etc. Right, up to infinity. The sum of infinite GP. A upon 1 minus R. Sum of infinite terms of GP. Right, A upon 1 minus R. What is the value of A? What is the value of A? 1. What is the value of A? It's 1. The first term. 1 minus common ratio. Common ratio is e power minus st. Okay. Now there comes, see, now there comes the condition due to which ROC can arise. Because it is a GP. Okay. And for the GP to converge, infinite GP to converge, modulus of R should be less than 1. Okay. So I should write that, I should now write down that modulus of e power minus st. Modulus of e power minus st should be less than 1. So, देखो, individually all of these terms were not seen to have any pole. Okay, not seen to have any pole. But can I decide a pole from here? There are two ways now. Okay, so this statement is no longer valid now. Is there no pole? Yes, there is going to be a pole. Because now after simplifying, I get a denominator term, which is 1 minus e power st. I can equate it to 0. I can equate it to 0. There are two ways of deciding that ROC. Either take the pole here or either put the condition of geometric GP, mod r less than 1. Okay, so if I take this condition and I'll just try to solve it here separately. Okay, so modulus of e power minus st less than 1. Okay, that means, okay, so e power minus st, the modulus of this less than 1. Okay, so e power minus st, yeah, if I talk in terms of minus st, it should be less than 0. It should be less than log 1 if I take log. Okay, if I take log. Okay, chalo, या पूरा sigma में ही निकाल देते. Let us do it for one and single time. Let's take a fresh slide here. Modulus of e power minus st should be less than 1. अच्छा, what is e power minus st? S की जगह रखा sigma plus j omega into t, whole modulus less than 1. Let me break this. Modulus of e power minus sigma t, modulus of e power minus j omega t. Whenever it is modulus of e power j theta, that is always equal to 1. Modulus of e power j theta is less than 1. So we are left with e power minus sigma t less than 1. Okay, okay. So exponential is a positive number, na? So e power anything is positive only. So you can remove the mod also. It is anyways positive. So there is no sense of mod. Okay, now I can write down minus sigma t, okay, less than log 1, okay, that is 0, right? So minus sigma t is less than 0, minus of sigma t less than 0, okay, minus is already there, okay, sigma cannot take any more minus, because if sigma is minus, 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 plus, but I want less than 0, so sigma should be positive only. Okay, so this gives you the ROC. That if I want modulus of e power minus st less than 1, the sigma should be greater than 0. That is the ROC. Okay, that is the ROC. Correct. The sigma should be greater than 0. Chalo, done. Sigma should be greater than 0. Okay, moving ahead to the next case then. Yeah. Next property, shifting in the S domain. So previous it was time shifting and now S shifting. Okay, if xt has the Laplace transform xs ROC equal to r, then e power s naught t into xt. Okay, there is an exponential term in the time domain, so there will be a shifting in the S domain. E power s naught t xt will have the Laplace transform x of s minus s naught. Right. E power s naught t xt has the Laplace transform x of s minus s naught. Now remember here, it is opposite sign. Okay, now ROC is r plus real part of s naught. Okay, if you want you can remember this, but I suggest not to remember because ROC will be solved by again the logic only. Now to explain you that logic, let me take up a question here. Okay, to explain you that logic, let me take up a particular question here. Okay, xt is e power minus at cos omega naught t ut. Okay, what we will first do is recall the cosine formula which we already know. What is the Laplace transform for cos omega naught t? Cos omega naught t into ut. The cosine, the cos and sine we know, and this was given by s is divided by s square plus omega naught square with the ROC sigma greater than 0. This is what we have already learned. Again, even if you forget the ROC for this cosine signal, how to remember? Logic. एक बार फिर से देखेंगे. Right. What is the pole? S square equal to minus omega naught square. So S is equal to plus minus j omega naught. Right. S is equal to 0 plus minus j omega naught. So what is the sigma? Sigma is 0. Signal is right sided. UT hai means right sided. So ROC sigma greater than 0. If it was left sided, sigma less than 0. But because it is right sided, sigma greater than 0. That is what I have written. Okay. But this is for the cosine signal. Now we want to find for e power minus at cos omega naught t ut. E power minus at cos omega naught t ut. Now what has been done is, this part Laplace transform is known, and to this part I multiply a exponential signal. To this part I multiply exponential signal. And multiply exponential signal, there will be shifting in the S domain. Okay. So S should now become S plus A. Here it is minus 80, so here it will become S replaced by S plus A. S plus A. Upon everywhere S will be replaced by S plus A. So denominator S plus A whole square plus omega naught square. What about the ROC? Now I told you can remember this formula for ROC, but no need to remember. Remember the basics. Pole se decide karenge ROC, right? Okay, so what are the poles of this? If I want to calculate pole, okay, denominator equal to 0, so S plus A whole square is minus omega naught square. So when I take the under root, S plus A is equal to plus minus j omega naught, under root of minus omega naught square. So what is S? Minus A plus minus j omega naught. Okay, and that means it is of the form sigma plus minus j omega, right? So what is the ROC? What is the ROC? By sigma kitna hua? If you compare both the terms, sigma is minus A. Okay, so ROC, sigma greater than minus A or less than minus A. But what is the type of signal? Unit step. So sigma should be greater than. Sigma should be greater than minus A. Sigma should be greater than minus A. That's it. The sigma should be greater than minus A. Done. So ROC is already obtained. No need to remember any other thing. The basics of ROC, that poles, right-sided, left-sided, everything that we have learned. Okay. This is e power minus at ut, cos omega naught t ut. So here we can frame some examples also. Suppose, these are some direct questions sometimes. Okay. Find the Laplace transform for, e power minus 2t cos 3t ut. E power minus 2t cos 3t ut. Okay, so what is going to be the Laplace transform? So its Laplace transform will be written as, okay, s plus 2, a का value 2 है, upon s plus 2 का whole square plus omega naught square, and omega naught is 3, so that is going to be 9. Just a second. That is going to be 9, right? Oh, sorry, not 9, it is 3 square. Okay, done. With the ROC, sigma greater than minus A, that is sigma greater than minus 2. That is a sigma greater than minus 2. Done. Chalo, cool. Let's move ahead. Okay. Similarly, if we have for cosine signal, let me write down the result for you directly. For the sine signal, like we derive for the cosine signal, e power minus at sine omega naught t ut, this will have the Laplace transform omega naught upon s plus a. Only s will be replaced by s plus a. Okay. Omega naught upon s plus a whole square plus omega naught square, again sigma greater than minus a. Okay, so this is what directly I can tell you now. Okay, this is directly can be written. Okay, moving ahead to the next property. Okay. Moving ahead to the next property, time scaling. If xt has the Laplace transform xs, ROC being r, xat will have the Laplace transform 1 by mod a x of s by a. Now there will be property based questions later on, mixed property based question bhi karenge. 1 upon mod a x of s by a. 1 upon mod a x of s by a, without ROC equal to AR, with the ROC equal to AR. Again and again I'm telling you, no need to remember this, just for formality I have given you, just focus on these properties. Okay, 1 upon mod A, X of S by A. Okay, time reversal, let's take some of the properties together. Okay, if xt has the Laplace transform xs, x minus t has the Laplace transform x minus s. Okay, ROC you will remember by logic. Okay, it will have the Laplace transform x minus s. Okay, conjugation. Now let me take some properties before going to another question. Conjugation. Xt has the Laplace transform xs. Okay, x conjugate t has the Laplace transform x conjugate s conjugate. This will have the Laplace transform x conjugate s conjugate, x star s star. Okay, x star s star with the same ROC. Differentiation in time domain. This is more useful, when you go to unilateral Laplace transform and talk about solution of differential equation. Okay, if xt has the Laplace transform xs, then d by dt of xt has the Laplace transform sxs. D by dt has the Laplace transform sxs. Okay. If xt has the Laplace transform xs, integration, that was differentiation in time, now that is integration in time. Okay. Integral x tau d tau has the Laplace transform xs by s. Integral x tau d tau has the Laplace transform xs by s. Okay. With ROC, forget ROC, we know how to remember. Okay, so I'm not focusing on ROC now because I have already given you quite hints. Okay, so it is divided by s. Differentiation in time, it is xas. Integration in time, it is xs divided by s. Okay. One more important result, when it is differentiation in the s domain, this is actually important. Okay, so if xt has the Laplace transform xs, minus t xt will have the Laplace transform d by ds of xs, differentiation in s domain. Okay, or we can write down this property as minus ko right shift kar denge. So what is the Laplace transform for txt? The Laplace transform for txt will be minus d by ds of xs, will be minus of the d by ds of xs, minus of the d by ds of xs. And this particular property is also known as a t times property. This particular property is also known as a t times property. Okay, this is also known as a t times property. Okay, when you multiply any signal by t. Now let's have, okay, a very important Laplace transform discussed with this. What is the Laplace transform for t e power minus at ut? What is the Laplace transform for t e power minus at ut? T e power minus at ut. Tell me. Laplace transform for t e power minus at ut. So let's start solving it. Because we know the Laplace transform for e power minus at ut, which is 1 upon s plus a, for t e power minus at ut, just like the t times property, the signal multiplied by t, Laplace transform here should be minus d by ds of xs. So it should be having the Laplace transform that is minus d by ds of xs, minus d by ds of 1 upon s plus a, minus d by ds of 1 upon s plus a, correct? And that is equal to then, differentiate this. Okay, 1 upon x differentiation, minus 1 by x square. 1 upon x differentiation is minus 1 by x square, right? That's it. Minus minus got cancelled. It is 1 upon s plus a whole square. It is 1 upon s plus a whole square. Now we can generalize this. Even the question could be now t square e power minus at ut. So if it is t square, that means one more t multiplied. If it is t square, means one more t multiplied. So one more time differentiation property. So one more time, minus d by ds of 1 upon s plus a whole square. Minus d by ds of 1 upon s plus a whole square. Okay, this will be minus 1 upon s square differentiation, minus 1 upon x square differentiation, minus 2 by x cube, minus 2 by s plus a whole cube. So minus minus again plus, this is 2 upon s plus a whole cube. Okay, generalize karenge. One more, if it is t cube e power minus at ut. If it is t cube, then And one more t multiplied to one more round of differentiation, minus d by ds of the above Laplace transform, 2 upon s plus a whole cube, right? So this will become how much? Minus 2 outside, 1 upon x cube. 1 upon x cube differentiation is minus 3 upon x power 4. So minus 3 upon s plus a ki power 4. This becomes 2 3s, that is equal to 6. Or you can write this was 2 na? Okay. This was 2. Here it is 1 into 2 into 3. It is 6, which is 1 into 2 into 3. This 2 can be written as 1 into 2 also. Divided by s plus a ki power 4. Right. So see, for t square it is 1 into 2. For t cube it is 1 into 2 into 3. Like this I can generalize. Okay, and I can generalize and I can write down, if I go up to t power n e power minus 80 ut. T power n e power minus 80 ut. If it is t power n, then it is going to be in the numerator. It is going to be 1 into 2 into 3 etc. up to n. Repeated multiplication, continuous multiplication from 1 to n, it is known as factorial n. So that is going to be nothing but factorial n divided by s plus a power how much? So see, t square power cube, t cube power 4. So if it is t power n, denominator s plus a ki power n plus 1. S plus a ki power n plus 1. S plus a ki power n plus 1, right? Hello. Yes, guys, there was, I think there was no audio, but now it is fine. Okay, let's check it up. Okay, yeah, let's continue. Okay, so x2s is 1 upon s plus 3 sigma greater than minus 3. Okay, now moving ahead, what is given to me? X2 minus t plus 3. X2 minus t plus 3. But let me first take t plus 3 because there is shifting and scaling both. Okay, so let's shift and then scale. So let us first focus on x2 t plus 3. x2 t plus 3 time shifting will have the Laplace transform 1 upon s plus 3 same multiplied by the exponential term e power 3s. Okay, and since there is the same pole, there is no change in the ROC. But now when I talk about x2 minus t plus 3, t plus 3 ki jagah minus t plus 3 means time folding has been involved. What is the time folding property? When you time fold, Laplace transform is also folded, x minus s. So here I will get minus s plus 3 and here also e power minus 3s. Okay, if t is replaced by minus t, s is also replaced by minus s, but will there be change in ROC? Look into this. Will there be a change in ROC? See, pole. Previous mein there was no change in the pole. But here, definitely the pole minus s plus 3 equal to 0, so s is equal to 3. S is equal to 3. x2t, the given original signal x2t is right-sided because it has ut. Because it has what? Because it has the ut. Clear? Hello. Yeah, sorry. Because it has the ut. Okay, but now minus t. What will minus t do? Take the mirror image. So if a signal was right-sided, now it should be left-sided. If a signal was right-sided, now it should be the left-sided. Okay, so this particular signal, because of doing the minus t, it is now left-sided. So based on these two, can I decide the ROC now? Pole is at 3, signal is left-sided, so ROC should also be left-sided. Left of what? Left of the pole, sigma less than 3. Now let us come to the question. Question mein kya bola hai? Okay, you have yt. Let us write down the yt given to us now. You have the yt which is equal to x1t minus 2, convolution with x2 minus t plus 3, right? Convolution in time corresponds to multiplication of the Laplace transform. So ys will be, first Laplace transform likhenge. What is the first Laplace transform? For x1t minus 2 you have the Laplace transform e power minus 2s upon s plus 2, multiplied by convolution converts to multiplication. For x2 minus t plus 3, look at the Laplace transform, e power minus 3s upon minus s plus 3. Now, what was the first ROC? Sigma greater than minus 2. For the next one, ROC sigma less than 3. So what is the final ROC? Whenever two different Laplace transforms are involved, whether it is linearity property or convolution property, whenever two Laplace transforms are involved, so you have to take the intersection. Okay, that means the ROC sigma is greater than minus 2 but less than 3. So minus 2 se 3. Minus 2 is less than sigma is less than 3. Minus 2 se 3. It is between minus 2 se plus 3. Correct? It is between minus 2 se plus 3. Done. Okay, now just let's simplify. Okay, so eventually y of s is equal to e power minus 2s minus 3s to e power minus 5s divided by this is going to be minus, starting with minus s square, and then you would be having 3s minus 2s plus s, correct? 3s and minus 2s and plus 6, minus s square plus s plus 6. Okay. With the ROC minus 2 less than sigma less than 3. So sometimes question clearly mention find with ROC. What is the property of ROC I applied in this question? there is no separate property of ROC I applied. I only applied the Laplace property like time shift property, time fold property, convolution property. But what I did for ROC, the basic connection, pole, right-sided signal, left-sided signal, that is what makes your ROCs always clear. That is what makes your ROCs always clear. That's it. This is what we have got. This is the YS, the expression, even with the ROC. Even with the ROC. So always just go always total conceptual. Okay, always total conceptual. Okay. Right, so just a quick update and reminder that that Monday to Friday you are getting the GATE 2024 fundamental classes. This is all the free material on the BYJU'S exam prep YouTube channel. Okay, you're also getting for computer science and ECE, you're getting the NIELIT crash course, that is Monday, Wednesday, Friday and Sunday. Right, Monday to Saturday for electrical students there is the ISRO series, the PYQ ISRO series. Okay, where we are discussing the very important previous year questions of ISRO so that you get practice and you get the idea about the level of ISRO exam. Coffee with Concept, the high quality conceptual recorded videos, okay, to make you understand important concepts in a very short span of time, like 10-15 minutes per video. Okay, you get this twice, Wednesday, Sunday for ECEE and Tuesday and Saturday for computer science. Learn with fun, okay, the practical based learning. Learn, okay, and now enhance your level of preparation, make your preparation more interesting through experiments being done, and this comes live at every Sunday at 7 p.m. Okay, the BYJU'S exam prep students success saga continues with 13 ranks under 10, 107 ranks under 100 and 62 students getting the rank under 50. Right, that's it for this session from my side. Okay, do not forget to subscribe to BYJU'S exam prep, GATE and ESE, ECEE in computer science channel. Bye bye, good night, stay safe and take care of yourself.